Welcome back, everybody. This is going to be part 3 of our homework review for lesson 36, the volume of pyramids and cones. And so this one is a little bit theoretical. No numbers here. It says the cone pictured has the same diameter as a cylinder, but only half its height. If the cone is used to fill a cylinder with water, how many of the full cones will be needed to fill the cylinder completely? And explain how you arrived at this answer. Now, you could use numbers, okay, but I'm not going to use numbers. I'm going to use letters, okay, because I want to compare the volume of the cone with the same exact letters as the volume of the cylinder. Now you're probably saying, does that mean they have the same volume? No, the same exact letters. So for example, they have the same diameter, okay. So if you call this D diameter and this D, that will mean they both have a radius of r. For both of them, okay? So I'll use that. So that's the idea. So radius equals r. Now, here comes the part that's going to be important. The height of the cone, I'm going to call h, okay? But the height of the cylinder, I'm going to use 2h. And they say, well, could I use h for the cylinder and use 1/2 h for the cone? Yes, you could. I'm going to use height h for 1h for the height of the cone and 2h for the height of the cylinder. And of course, they have the same radius. So this is r, but so is this. This is r as well too. Okay, and so the volume of the cylinder is pi r squared times the height. But the height here is going to be, so with not h, but instead we have pi times the radius squared times 2h, because that's the height of the cylinder. And so when we multiply everything out, we're going to get 2 pi r squared h. Now the volume of the cone, that's 1/3 pi r squared times h, and that's the same h. So, all right. So they have the same exact letters. R. Oops, I the r here. Sorry, r squared times h. And so we have the volume of the cylinder in terms of r and h, and the volume of the cone in terms of the same r and h. So how many times will the cone go in the cylinder? This will be one of those division problems, because it's really dividing in this case. How many times can I divide something into something else? So we're going to now have the following division problem. 2 pi r squared times h, that's the volume of the cylinder, divided by the volume of the cone. And that's going to be 1/3 pi r squared h. And we notice that certain terms we can simplify out. For example, the pi is divided out because pi over pi is going to be just 1. So is h over h. H over h is 1. And so is r squared over r squared is 1. So we're left with a value here of 2 over 1/3. Now we will use, in this case, what we normally do with dividing fractions. This is the same thing as 2 divided by 1/3. And some of you guys learned this whole thing with dividing fractions. We'll keep the first number the same, change the multiplication to division to multiplication, and take the reciprocal or flip the second fraction. So also known as keep, change, flip. All right, I know some of my colleagues are like, oh, it's terrible. Well, you know what though? This is a kind of an easy way to remember certain things. So hopefully if this helps, it helps. So 2 times reciprocal of 1/3 is 3. And so we have, in this case, 6. This means we can make a final statement here, which I'll type out because my handwriting is dreadful. So, ladies and gentlemen, we will say we can fill the cylinder with the cone. Well, let's see, the fill cylinder by using the cone 6 times. Okay, really meaning in this case, you're gonna need to fill the cone 6 times to pour into the cylinder. I should write it down. That's okay. Right? So we can fill out the cylinder by using the cone 6 times. Okay, so really, because it has the same exact radius, but the height of the cone is half a cylinder, we're going to need this to be 6 times. Now, the funny thing is this, you might just say, well, you know what, I don't have to show all this. Normally, if they have the same exact radius and the same exact height, because they have the volume of a cone is 1/3 that of a cylinder, I would need to fill it 3 times. Well, if it's 2 times height of the cylinder, well, 2 times 3 is 6. Keep in mind, however, that we want to compare dimensions. If the radius was twice, it would not be 6. It'd be, in this case, it would be quite different, actually. So you have to keep in mind, it's very important to be able to show the comparison of these two volumes using the same exact letters. Now, if you want to use numbers too, if you made the height 1 and the radius 1, and for the height for the cone, and the height of the cylinder 2 and the radius 1, you would still get, in this case, the same situation, 2 divided by 1/3, and you would get, in this case, 6 cones altogether. If I change the dimensions, so it's still the same way, let's say, for example, the height was 10 for the cone, and the height of the cylinder was 20, and the radius was 1, I'd still end up getting a simplified value of 6 cones to fill in the cylinder. So, full page here. All right, so how many full cones we needed? We'll need to use a cone 6 times to fill the cylinder completely. Now, ladies and gentlemen, I hope this is helpful. And the approach to this, again, we could use numbers, but one of the things about numbers is that some might say, well, it only works for those numbers. Well, one might argue that be true, and as we test out all these different numbers, it's totally good. But if I use, in this case, very much like a proof, where instead of using numerical values, we are using, in this case, theoretical letters to represent, like, here, dimensions or heights and radii, but keeping them in the corresponding the same unit, if you will, of letters R and H, is we can see the comparison, because things will just simplify out. And this is a technique you might want to be using later on to show other things as well too. So this is the end. This is the end of part 3 and the last of our questions for homework number 36, the volume of pyramids and cones. I hope this was helpful. Please leave your questions and comments in the comment section below, as well as feedback. I look forward to hearing anything that you might think would be helpful. I appreciate all comments. If you found this video helpful, please give it a like. We really appreciate it here. And if you have not done yet, please subscribe to the channel. And turn on notifications to be notified when new videos will be added to the channel. During the summertime, like I said, I'm going to probably work on Algebra 2 videos and even go back to Algebra 1 or maybe even previous geometry question lessons, so that you can kind of go back and catch up on things as well too. So hopefully you guys, when fall comes, when you have the topics of Algebra 2 and other topics and all, that will be prepared for those classes as well, because the main thing is knowledge, knowledge, so you guys learn stuff and all. Anyway, thanks so much for watching. Please keep safe, take care, and see you in our next video.